Hello, y'all. I am glad you're here for the rational and irrational numbers quick check. All right, so the first thing we need to talk about is what is an integer? So an integer is either a positive or negative number, and it includes 0. But integers are not decimals, integers are not fractions. Integers are whole numbers that are either positive or 0 or negative. So these are the examples right here that it gives you. But let's go over here and check each of these. So the first one is 7. We're going to circle all the ones that are integers and we're going to mark out the ones that aren't. Well, 7 is a positive whole number, so that will work. So we're going to say, yes, that is an integer. Negative 16. Well, 16 is a whole number, and a whole number just means it's not a fraction or decimal. It's just a nice whole number. And since integers include all the negative whole numbers, negative 16 would work. 0. Integers do include 0, so 0 would work. Square root of 16. Well, we have to ask ourselves, what is the square root of 16? And the square root of 16 equals 4. And 4 is a positive whole number, so this one would work. All right, so let's check out the square root of 7. If you type the square root of 7 in your calculator, it's going to give you some weird decimal. It's going to be 2.645, on and on and on. This one is not a nice whole number, so it is not an integer. This one does not work. 1/2. 1/2 is a fraction, or you can rewrite it as a decimal, 0.5. Integers do not include decimals, so this one does not work. But I threw this one up here. This is a tricky one. If you divide it, 10 divided by 2 is 5. This actually equals a positive whole number, and a positive whole number is an integer, so this one does work. So I don't want you to think just because you see a square root that it's not. You need to solve it and see what it equals to determine whether or not it is an integer or is not. Same thing with a fraction. Don't just automatically assume if you see a fraction that it's not an integer. Go ahead and divide to see what you get. If you get a decimal, it's not an integer. If you get a whole number, then it is. All right, so let's look a little bit more into the real number system. And this is a really great graphic organizer, so I have this on most of our slides. Down here we have our natural numbers. Those are just like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whole numbers are the same thing. They just include 0. Integers, they include 0, the positive numbers, and the negative numbers. After integers, we get into rational numbers, and these can be fractions and decimals. So when you have rational numbers, you can also have fractions and decimals. The thing about rational numbers is if it's a decimal, it has to end or repeat. And then you go over here to irrational numbers. Irrational numbers are decimals that do not end and they do not repeat. And then real numbers is every single type of number we are talking about. So all of these are real numbers. Irrational are real, rational are real, integers are real, whole numbers are real, and natural numbers are real. When you get to geometry in the 10th grade, you'll start looking at imaginary numbers. But for right now, we're just dealing with the real number system. So we want to label each statement as true or false. Every irrational number is a real number. Well, yeah, irrational is a real number, so that is true. The next one, the number 0 is a rational number. Well, if we look at our rational numbers, it does include the number 0, so that's also true. Every integer is a real number. Every type of number we're talking about right now is a real number. Notice real number is this giant square and everything is inside of it. So that is true. Every integer is a real number. Every real number is a rational number. Okay, well that one is not true because these numbers over here are also real numbers. These irrational numbers, pi is a real number, but it is not rational. Notice how these are not inside this circle here. So irrational numbers are real, but they are not rational. So this statement is false. Let's keep going. Which number is not the same type of number as the others in the list? All right, here we have 7.35. If we go back to our chart, that's a rational number. It's a decimal that ends. So this one is rational. We have 6.93572 ... This decimal does not end, that's what the ... means, and it does not repeat. So this one is irrational. Here we have 2.625. It ends, so it's a rational number. And here we have 82.4. That ends, so that's a rational number. So the one that's different here is this one because it is irrational. It does not end and it does not repeat. All right, how would you change this sentence to a true statement? So it's telling you right now that this is already false. Let's read it. Some irrational numbers are also rational numbers. So if we think about irrational, they're out here, and rational's in here. In this Venn diagram, they never cross. A number either has to be irrational or rational. It can't be both. So instead of saying some irrational numbers are also rational, we need to say no irrational numbers are also rational. So you just need to change that. Instead of some, you can say irrational numbers are never also rational, or you can say none or no. You just need to know that they can never be the same. An irrational number cannot be a rational number. I'm going to put no irrational numbers are also rational. Okay. For this one, how would you change the sentence to a true statement? It says every irrational number is an integer. So if we're over here looking at irrational numbers and it's saying that they are integers, that is not true. Irrational numbers are numbers that never end and never repeat. So that's just not true. But if we keep is an integer and we just try to fix this first part, we know it's not every irrational number. Let's see what every kind it is. So if we look over here at integers, every whole number is an integer and every natural number is an integer because they're within that blue integer circle. So if we wanted to make this a true statement, we could say every whole number is an integer, or we could say every natural number is an integer. Those are the two ways that we could make that statement true. All right, I hope this helps. Good luck on your quick check.